In last video we have to learn about the limits, function and limits. So definitions, some problems we will learn. Now in this video we have to learn the remaining problems. We have to learn remaining problems. We have to learn remaining problems. So last video, limit extends to a can be having the 1 to 3 numbers. For example, we are taking the limit x tends to 2 x plus 2 by 2x plus 4 x plus 2, like this. So we are substituting the x values and getting the answer. Another one, we are getting the answer. What we are getting here? 4 8 4 by 8 means 1 by 2, like that. Otherwise 0 by 0, otherwise 0 by 0, undeterminate form. Now second method, we are having the limit x tends to 0. X can be replaced by 0. X can be replaced by 0. X can be replaced by 0. So another method is x tends to infinity. X tends to a, x tends to 0, x tends to infinity. Now we have to learn x tends to 0 values problems. X tends to 0. First we are taking one question, that is, first question is limit x tends to 0 x by under root 1 minus under root 1 minus x, 1 minus under root x. So when you are substituting the 0 by 0, 1 minus under root 1 minus 0, that is 0, 1 minus root 1. Root 1 value is 1 only. 0 by 1 minus 1, that is equal 0 by 0, that is equal to 0 by 0. Again we are getting the undetermined value. So in that time we did the factors. When you are undetermined, one method is we did the factors. Now we here in this problems we can't get the factors. Now we are doing the rationalizing the denominator. Rationalizing the denominator. Limit x tends to 0 x by 1 minus under root 1 minus x. So we are multiplying and dividing by 1 plus under root 1 minus x by 1 plus under root 1 minus x. Rationalizing here, if you are assuming this one is a minus this one is b, this one is a plus b, a minus b, a plus b, so that is equal to a square minus b square. In denominator we are having here a plus b into a minus b, that is a square minus b square. Limit x tends to 0 x of 1 plus under root 1 minus x by a square minus under root 1 minus x whole square. Square root get cancel here. Limit x tends to 0 x of 1 plus under root 1 minus x by 1 minus 1 minus x. So that is limit x tends to 0 x of 1 plus 1 minus x by minus 1 plus x. Plus minus get cancelled. That implies what we are getting here. Next we will get limit x tends to 0 x of 1 plus under root 1 minus x by x. This x get cancelled. Remaining limit x tends to 0 1 plus under root 1 minus x. Now we are substituting the x is equal to 0. 1 plus under root 1 minus 0, that is equal to 1. Root 1 value is 1, that is answer is 2. So when we are getting the undetermined value of, if you are not able to take the factors. If you are not able to take the factors, we have to do the rationalizing the denominator. See once again the problem. Limit x tends to 0, x by under root 1 minus under root 1 minus x. So when you are substituting the x is equal to 0 here, 0 1 minus root 1 minus 0. So 1 minus 0 is 1, root 1 value is 1, 1 minus 1 is 0, 0 by 0 is undeterminate. When we are having the undeterminate form, in that time what we are doing here, where we have to find the factors. So here not able to do the factors, that's why we are rationalizing the denominator. We are rationalizing the denominator, that is 1 minus. So denominator contain here 1 minus under root 1 minus x. So we are changing the symbol here, we are changing the symbol, minus having here, we are taking a plus, multiplying, dividing. So when we are multiplying and dividing here, in that time value cannot be changed. This one get cancelled, get the 1 into something is something. Again we will get the question, So when we are doing the rationalizing denominator, we are multiplying and dividing the both values, same values, multiplying and dividing here. So that is denominator what we having here, 1 minus under root 1 minus x, 1 plus under root 1 minus x. So in these two places, one can be assuming as a, this one is b, a minus b, a plus b. This is the form of a square minus b square, a square minus b square. Now limit x tends to 0, limit x tends to 0, x of 1 plus under root 1 minus x square. So denominator a square means 1 square, b square means root 1 minus x whole square, square root get cancel, remaining in denominator 1 minus of x minus 1. We are multiplying with minus into plus, minus into minus, plus 1 minus 1 get cancel here. Next we will get here limit x tends to x 1 plus under root 1 minus x by x get cancel here. Now we are substituting the value, in that time we will get the 2. Now we have to see the another problem. That is limit x tends to 0, root 1 plus x minus 1 minus x by 2x, 1 plus x minus 1 minus x by 2x. So here what we are doing here, first of all we have to substitute the 0, root 1 plus 0 minus 1 minus 0 by 2 of 0, that is equal, root 1 value is 1 minus 1 by 0, that is 0 by 0. Again we are getting the undeterminate form, when you are getting the undeterminate form, we have to do the factors, we have to find the factors. We can't able to find the factors here, that's why we are doing the rationalizing. So rationalizing, in numerator having the numerator having here two parts, so we have to do the here numerator part rationalizing, numerator part rationalizing we are rationalizing here. Numerator part rationalizing here, that is limit x tends to 0, root 1 plus x minus root 1 minus x into 2x. We are multiplying, dividing by root 1 plus x plus root 1 minus x by root 1 plus x plus root 1 minus same value. When we get these numerator and denominator same value, get cancelling 1 into something is, again we will get the question. Here this one is a, this one is b, this one is a, this one is a minus b, a plus b, that is equal to a square minus b square. Limit x tends to 0, that is equal to root 1 plus x whole square minus root 1 minus x whole square by 2x of root 1 plus x plus root 1 minus x. Here square root it cancel, limit x tends to 0, 1 plus x minus of 1 minus x by 2x of the root 1 plus x plus root 1 minus x, root 1 minus x. Limit x tends to 0, 1 plus x minus 1 minus and minus plus x. Here plus, here minus, plus into minus minus 1. Here minus into minus plus x by 2x of under root 1 plus x plus root 1 minus x, that is equal to, so here minus 1 plus 1 get cancel, x plus x 2x, limit x tends to 0 2x by 2x under root 1 plus root x plus root 1 minus root x. Here 2x get cancelled, 2x get cancelled. Remaining what we have here, limit x tends to 0 1 by root 1 plus x plus root 1 minus x, 1 plus x by root 1 minus. Now we are substituting the limit x can be replaced by 0, that implies x can be replaced by 0, that is 1 by under root 1 plus 0 plus under root 1 minus 0, that implies 1 by root 1 value, root 1 plus root 1, root 1 value is 1 by 1 plus 1, that is equal to 1 by 2. This is our solution. See once again here, what is our question? Limit x tends to 0 root 1 plus x minus root 1 minus x by 2x. So first of all, where x can be replaced by 0, in that time we are getting here undeterminate form. When we are having the undeterminate form, we have to find the factors or rationalizing. So we can't get the factors here, that's why we are doing the rationalizing the numerator. We are rationalizing the numerator, that is root 1 plus x minus root 1 minus x into root 1 plus x plus root 1 minus x by root 1 plus x plus root 1 minus x. So numerator containing here a minus b, a plus b, that is a square minus b square form. In that time, after simplification, we are getting here 1 by this value. So we are substituting the all x is equal to 0, in that time we will get the 1 by 2. Now we have to see another problem. Now we have to see the another problem, that is so see the next method. When you have the limit x tends to 0, x tends to infinity. Next one, x tends to, when you have the x tends to infinity, so in that time tan 90 value, tan 90 degrees infinite na, tan 90 is equal to infinite, tan 90 infinite na, that is sin 90 by cos 90 na, sin 90 is 1, cos 90 is 0, something by 0, infinity na. So 1 by infinity is equal to, so we are sending this one this side, this one this side. 1 by infinity value is 0 na. So when we are having the x tends to infinity, 1 by x tends to 1 by infinity, 1 by x tends to 1 by infinity. So 1 by infinity value is 0, 1 by infinity value is 1 by x tends to 0, 1 by x tends to 0. So when we are having the infinity, we can't substitute the limit value infinity. That's why we are doing here 1 by infinity. We are converting to 1 by infinity value 0. So tan 90 value is infinity, sin 90 by cos, sin 90 value is 1, cos 90 value is 0. So it's equal to infinity na. So we are changing 0 this side, infinity this side. In that time we are getting here 1 by x, 1 by infinity. So when we are having the x tends to infinity, we are replacing by 1 by x tends to 0. When we are having the x tends to infinity, that can be replaced by 1 by x tends to 0, 1 by x tends to 0. In this method, we have to do some two problems, more problems. We are having several problems. First question. The first question What is that? First question is limit x tends to infinity 4x plus 5 by x square plus 2x plus 3. So we can't substitute the x tends to infinity. We can't not able to substitute the infinity value in x place. So for that, what we are doing here, we have to convert 1 by x tends to 0. 1 by x tends to 0. For that, we have to take the highest power of variable. Highest power is 1, so we have to take the x common here. Here highest power is square, we have to take the x square common. Limit x tends to infinity, so we are taking here x common. X common means x plus 5 by x. So when we are multiplying here, 4 into x, 4x. Here x get cancel, 5. In denominator we have to take the x square common. Denominator we have to take the x square common, that is 1 plus 2 by x plus 3 by x square. See here, otherwise 4x plus 5 can be divisible by x, that means 4. Multiplying and dividing by x, x it cancel, same value, that is equal to x of 4x by x plus 5 by x get cancelled, that is equal to x of 4 plus 5 by x, 4 plus 5 by x. So this one in denominator see here, x square plus 2x plus 3. Highest value is what we have here, highest power is 2, so we are multiplying and dividing by x square by x square. So x square we are putting as it is, we are dividing the every term, x square by x square plus 2x by x square plus 3 by x square, that is equal to x square get cancel, x square of 1 plus x get cancelled, 2 by x plus 3 by x square. So directly I am right here. So here x get cancelled. Limit x tends to 0 of numerator 4 plus 5x, in denominator x of 1 plus 2 by x plus 3 by x square. Here infinity na, so if x tends to infinity, 1 by x tends to 0. X tends to infinity, 1 by x tends to 0, so that is 1 by x tends to 0. 4 plus 5 of 1 by x, 1 by x, denominator x na, 1 by x, 1 plus 2 of 1 by x plus 3 of 1 by x whole square, 1 by x whole square. Now we are substituting x is equal to 0. 0 of 5 of 0 by 1 plus 2 of 0 plus 3 of 0. That is equal to 0 of 4 plus 0, 1 plus 0 plus 0. 0 of 4 by 1, that is 0 into something is 0. 0 into something is 0. So when we see the question, so when the powers are same, when the numerator power, polynomial power, denominator polynomial are same, in that time we'll get the answer, otherwise we'll get the 0. See the question once again. Limit x tends to infinity 4x plus 5 by x square plus 2x plus 3. So when we are having the x tends to infinity, we can't substitute unable to substitute infinity value in x place. Infinity means undeterminate value. How can we substitute? We can't substitute na. So that's why if x tends to 0, x tends to infinity, in that time 1 by x tends to 0. Limit x tends to infinity, x by x square 4 plus 5x, that is equal to, so we are taking the x, we are simply numerator product, denominator product, we are finding the simplification we did here, substituting these values. X tends to infinity, 1 by x tends to 0. So 1 by x, here I am 1 by x, here I am 1 by x, 1 by x, 1 by x whole square, 1 by x whole square, 0 square value is 0. That means we will get the at last, so 1 by x having a something, 0 into something is 0. See, now we have to see the another question. Next we have to see another question, that is limit x tends to infinity, 5x square plus x plus 1, 6x square by 6x square minus 3x plus 1, numerator and denominator. We can't substitute the infinity value, that's why highest power is x square, so we have to divide the x square, or we have to take the x square common in numerator and denominator. Limit x tends to infinity, we are taking the x square common, otherwise multiplying and dividing by x square. 5 x square by x square plus x plus 1. So this x square get cancelled. Denominator also same. X square of 6x square minus 3x plus 5 by x square. This x square get cancelled. So here x square get cancelled. That is limit x tends to infinity of 5 x square by x square plus x by x square plus 1 by x square plus 1 by, this is numerator, denominator also same, 6x square by x square minus 3x by x square 3x square by x square plus 5 by x square plus 5 by x square get x denominator x square x remaining limit x tends to infinity 5 plus 1 by x plus 1 by x whole square, denominator also 6 minus 3 of 1 by x plus 5 of 1 by x whole square, 1 by x whole square. Here x tends to infinity, then 1 by x tends to 0. X tends to infinity, 1 by x tends to 0. That is limit 1 by x tends to 0. Limit 1 by x tends to 0. That is 5 plus 1 by x plus 1 by x whole square by 6 minus 3 of 1 by x plus 5 of 1 by x whole square. So see here, substituting x is 1 by x is equal to 0, 0, 0, in this plus 0, in this plus 0. So here 0, here 0, that is equal to 5 plus 0 square by 6 minus 0 plus 5 of 0 square, that is equal to 5 by 6, that is equal to 5 by 6. So when we are having the powers are equal, equal, here numerator power is 2, denominator power is 2, directly we have to write the answer 5 by 6. We have to write the numerator coefficient, highest power coefficient, denominator highest power coefficient is our answer. Here coefficient is 5, here 6, 5 by 6, that is our answer is 5 by 6. See the another one, limit x tends to 0, x cube plus 4 by x cube minus 4, x cube plus 4 by x cube minus 4. Answer is 1. Answer is 1. Because why we are saying infinity na? We are saying here highest powers are equal, 3, 3. This coefficient is 1, this coefficient is 1 by 1 is 0. Now we have to do the method. So limit x tends to infinity. So we are taking here x cube common. There is 1 by 4 by x cube. Here denominator x cube of x cube minus 1 by 4 by x cube. So here 1, x cube get cancelled. Limit x tends to infinity, that is 1 plus 4 of 1 by x whole cube, 1 minus 4 of 1 by x whole cube. If x tends to infinity, 1 by x tends to 0. So limit x tends 1 by x tends to 0, that is 1 plus 4 of 0 cube minus 4 of 0 cube, that is equal to limit 1 by x tends to 0, 1 plus 0 by 1 minus 0, that is equal to 1 by 1. So when we are substituting the values, no need to write the limits, that is 1 by 1 value is 1, 1 by 1 value is 1. Next we have to see limit x tends to infinity x plus 1 by x. Directly we have to write the answer 1, because x square numerator polynomial power variable power is 1, denominator variable power is 1, so powers are equal, then directly we have to write the answer 1. So as a method we have to take the x common. X, if you are taking the x common, 1 plus 1 by x, x common 1 plus 2 by x, limit x tends to infinity. This x get cancel, x tends to infinity, 1 by x tends to 0, 1 by x tends to 0, that is equal to 1 plus 0 by 1, 2 of 0, that is equal to 1 by 1, 1 by 1, that is equal to 1. Now we have to see the another problem. That is limit x tends to infinity, limit x tends to infinity, x of limit x tends to infinity, x of under root x square plus 4 minus x. See here, so we can't substitute the infinity value. We are not taking to, no, if you are, we can't take the common. If you are taking the powers common, in that time we can't multiplying it. So first of all we are rationalizing the numerator, otherwise. So that is limit x tends to 0, x of under root x square plus 4 minus x into x into root x square plus 4 plus x by root x square plus 4 plus 4 plus x plus x. See here, this one is a, this one is b, this one is a, this one is b. That is equal to limit x tends to infinity, x tends to infinity, x of root x square plus 4 whole square minus x square. Here a minus b, a plus b is equal to a square minus b square. So that is denominator x square plus 4 plus x. So that is limit x tends to infinity, x of square root, it cancel here, x square plus 4 minus x square by. So in these terms we are taking the x square common. X square common means x 1 plus 4 by x square plus x plus x, minus x plus x square get cancel, limit x tends to infinity, x of 1 4 by root a b is equal to root a root b. We have to write root a b is equal to root a root b. This one is a, this one is b, in that root whole square root 1 plus 4 by x square plus x, square root it cancel here, limit x tends to infinity, 4x by, so here x of under root 1 plus 4 by x square plus x. These two terms we have to take the x common, x that is equal to limit x tends to infinity, 4x by x common 1 into 1 plus 4 by x square plus 1, x get cancel, limit x tends to infinity, 4 by 1 root 1 plus 4 by x square plus 1. If x tends to infinity, 1 by x tends to 0, x tends to infinity, 1 by x tends to 0, limit 1 by x tends to 0, 4 by under root 1 plus 4 of 1 by x whole square plus 1, that is equal, now we are substituting the value, that is equal to 1 plus 4 of 0 plus 1, 4 plus 0 plus 1, 4 root 1 value is 1, 1 plus 1, 4 by 2, that is equal to 2, that is equal to 2. Now we have to see another problem. Limit x tends to 0 root 5 plus 0 minus root 5 minus 0 by x. So now we are substituting the x value plus 0 root 5 minus 0 by 0, that is equal to root 5 minus root 5 by 0, that is equal to 0 by 0, undetermined. Now, so when we are having the undetermined, we have to find the factors of, otherwise rationalizing. So here we have to do the rationalizing. X tends to 0 root 5 plus x minus root 5 minus x by x into root 5 plus x minus 5 minus x, here plus root 5 plus x plus root 5 minus x. So here this one is a, this one is b, minus a plus b. So limit x tends to 0 root 5 plus x whole square minus root 5 minus x whole square by x of root 5 plus x plus root 5 minus x. 5 minus square root it cancel here, square root it cancel here. Limit x tends to 0 5 plus x minus 5 minus x by x of root 5 plus x plus 5 minus x. Limit x tends to 0 5 plus x minus 5 plus x by x of root 5 plus x plus root 5 minus x. Minus 5 plus 5 get cancel, x plus x to x. Limit x tends to 0 2x by x of root 5 plus x plus root 5 minus x. Here x get cancelled, that is equal to limit x tends to 0 2 by root 5 plus x plus root 5 minus x. So substituting the value 2 by root 5 plus 0 root 5 minus 0, that is equal to 2 by root 5 plus root 5, that is equal to 2 by 2 root 5, 2 get cancelled, that is 1 by 5, 1 by root 5, that is 1 by root 5. So in this class we are learning the two methods. When we are having the in this class we will learn the two methods. First one, limit x tends to a. In last video, in this video we have to learn the two methods, limit x tends to 0, limit x tends to infinity. So when we are having the limit x tends to 0, in that term we will get the undetermined form. Undetermined form. When we are in the undetermined form, we have to find the factors are rationalizing. Factors are rationalizing. We are finding in first problem x by 1 minus under root of 1 minus x. So in these problems we can't find the factors, we can't able to find the factors. So for that, what we are doing here, we are doing the rationalizing. When we are doing the rationalizing, we will get cancel the negative terms. Totally will get cancel the negative terms. We have 1 minus x square can be vanished into x terms. So at last we will get this value. At last we will get these values, that is equal to this answer. First problem. Second problem, limit x tends to 0, this one, limit x tends to 0, this one also same method, rationalizing the numerator. When we are getting the undetermined form, we are rationalizing the numerator rationalizing the numerator. In the term we are getting the numerator constant value, denominator we are having the all positive terms, root x plus 1 plus root x minus 1. If you are having in the question you are having the minus, when we are subtracting the minus 0, root 1 minus root 1 0. So here root 1 plus root 1 plus root 1 1 by 2. Next problem, next third problem, when we are having the 0, this one, when we are having the 0, denominator same method, numerator having the rationalize the numerator. In that time what we are writing here, we are writing the simplification at last 2 by under root 5 plus x plus 5 minus x. So now we are substituting the values. In that time we will get the root 5 answer. When we are having the infinity, in that time they are having the three problems. First problem is limit x tends to the infinity 4x plus 5 x square minus. These limit infinity problems. So see the once I am explaining here same problems. So when we are having the infinity, we can't substitute the infinity value. For that, generally we have to know about the tan 90 value is infinity, sin 90 by cos 90. Tan 90 can be replaced with sin 90 by cos 90. Sin 90 value is 1, cos 90 value is 0, is equal to infinity now. So we are sending infinity this side, 0 that side. That is equal to 1 by infinity. 1 by infinity is equal to 0. So x tends to infinity means 1 by x tends to 1 by infinity. 1 by infinity value is 0. That is 1 by x tends to 0. X tends to infinity means 1 by x tends to 0. Now we have to see the problem. Already we learned. So once I am explaining here. Limit x tends to infinity 4x plus 5 x square plus 2x plus 3. So x tends to infinity and 1 by x tends to 0. 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 So limit x tends to infinity. Here highest power is 1, x variable power is 1, x variable power is 2, numerator x variable power is 1. So we have to highest power variable taking the common. So here taking the x common, that is 4 by 4 plus 5 by x. Here x square common, so x square 1, 2 by x, 3 by x square, 3 by x square. So x that will get cancelled, remaining 1 by x, 4 plus 5 by x plus 1 by 2 by x plus 3 by 4 by x square. So x tends to infinity now, 1 by x tends to 0. So substituting the values, in that time 1 by x tends to 0, we will get the 0. Why we are getting the 0? Here 1 by x tends to 0. 1 by x tends to 1 by x can value 0. 0 and something is 0 plus 0. See the second problem. Limit x tends to infinity. Limit x tends to infinity. Here x square, numerator variable, numerator degrees 2, denominator degrees 2. When the degrees are equal, in that time the coefficients, highest degree coefficients are answer. Highest degree coefficients are answer. 5 by 6, 5 by 6. So here x method we are taking the x square common. Otherwise x we are multiplying and dividing the numerator x square and dividing the dx square. X square and x square, it cancel. We are dividing here. In last we are getting here 5 plus 1 by x plus 1 by x whole square, 6 minus 3 1 by x plus 5. X tends to infinity and 1 by x tends to 0. Substituting the value, in that time what we are reading here, 5 by 6. Next, see here, x cube, degree is 3, degree are equal, numerator degree and denominator degree equal. Highest degree coefficients are our answer. Highest degree coefficients are our answer. 1 answer is 1. When we are method, we are taking the x cube common. In that time we are reading this one. When x tends to infinity means 1 by x tends to 0. Substituting the value, in that time we will give the 1. Next, see the another problem. Limit x tends to infinity 1 x plus 1 x plus 2. So highest degree is 1, numerator degree is 1, denominator is 1, coefficient is 1, 1 by 1 is equal to 1. So otherwise method means we are taking the x common, 1 by x tends to 0, 1 by x tends to 0, answer is 1. Next, last problem, tends to infinity. So here denominator not having only numerator. So when we are having the numerator, we can't substitute the value. That's why we are doing the rationalizing. When we are doing the rationalizing, in that time what we are reading here, we will get this value, x into 4 root x square, that is equal to x square. Cancel it last, we are substituting the value. See once again these problems are most important of exam point of view. If you learn these problems, you will get the good marks.